Stats week 2 recording. So nice to have you with us, and let's launch straight in and have a look at the subject guide. For this week, week 2, don't forget, we'll remind you in when we get together in our Teams class that we've got a 1-hour quiz next week. We'll do a little bit of practice when we get together in class to help you get your head around multiple choice questions. We've got 3 chapters to do today, 5, 6, and 7. So probably the best way to break this is to break it into 3 recordings. So I've actually done, I plan to do 3 recordings, 1 on chapter 5, simple interest, 1 on chapter 6, compound interest, and 1 on chapter 7, annuities. Break it into 3 component parts. So you don't have to find an hour, maybe just find, 3 20-minute segments. I can't guarantee they'll all be 20 minutes. Some may be 15, some may be 10, some may be, but we'll just work out. We'll just do what we need to do to get through the material. It's an overview, and you might have covered some of this material before, but let's launch straight in. The main tools we'll be using today will be PowerPoint and Excel. So let's launch in and see what we can do. So there it is, that just 10%, that's a good point for our quiz next week. Might as well get off to a flying start. So just another reminder for that's coming up. On weeks 1 and 2, 5 chapters being covered in that 30 multiple choice questions. Well, look, there are 5 transactions. The first video will be looking at simple interest. The second, on chapter 5, second chapter, chapter 6, compound interest, is where we just have a single amount, a one-off amount being invested and seeing what it will grow to. Alternatively, knowing what the future value might be and then converting it back to a present value today. Again, these items 2 and 3 are questions just involving a one lump sum. So when you read a question there, you're looking for, the giveaway is that, Joe Bloggs invests $1,000 at such and such a time and leaves it there for 3 years. Something like that gives you an idea that, no, this is just a lump sum. Whereas items 4 and 5, chapter 7, is annuities. Now, annuity really just means a regular deposit and a regular amount, if you like. And so there, the question hopefully will be pretty clear. Joe deposits $500 a month for the next 3 years. What will it grow to? So pretty clear that this one is an annuity style question. And the other way of turning that around is converting a lump sum today into potential future income streams, possibly. So receive a lump sum today, a loan. So a loan will always be a present value. You get that amount today. And then you try and work out, well, what are the future income future income or repayments that will be the equivalent of that loan amount. So the same thing might be for a person retiring. Invest a single amount today. So there's a cash outflow. And what future income stream, annuity, might you expect to receive from that? So they're the 5 styles of questions we'll be looking at this week. Why have we got interest anyway? It really is tied into what's going on with inflation. It's a reward for the fact that prices are going up. So if you invest some money, for example, your reward is that you will be earning some interest to the fact that prices are going up. It's compensating you for that. Due to COVID-19, we are in a period for the first time, deflation, first time in 22 years. So we could expect inflation rates to remain quite low. And this is an article coming from The Australian, and that says it all. Well, look, there are formulas. This formula is straight from your textbook. You can use a formula for simple interest. My preference is to try and solve a question just using common sense. So two ways to do it. If you're a formula type person, use the formula. But if you want to follow my technique, then let's just keep applying common sense. And the key for solving it without a formula, the key is you're always looking for 1 year's worth of interest. Once you find 1 year's worth of interest, you can do anything because it's flat, because it's a simple interest, flat rate of interest doesn't change. So let's have a look at it. Calculate the simple interest earned on a $15,000 deposited at a rate of 1.5% per annum for a period of 2 years. Well, look, we could use the formula and just plug the data in. Oh, $15,000 is the amount. The rate is, notice we're entering the rate as a decimal, 1.5% from last week's topic. Got to move the decimal 2 to the left. 0.015 times 2 years, the terms, and we get the answer. My preference is really just to, our concept is, look, just get 15,000, multiply 1.5%. That is 1 year's worth of interest, then just multiply it by 2. Did we really need a formula to do that? I don't think so. What about this part B, 4 years and 3 months? So we really want to convert 3 months into what proportion of a year is that? So 3 divided by 12 will give us 0.25. So the term is 4.25, if you like. So let's work out what 1 year's worth of interest is. 15,000 times 1.5%. There's 1 year's worth of interest. And now multiply it by 4.25. And we'll get their answer, 956.25. Now, we've got to be careful that we read the question carefully. If the question asks for simple interest, give them simple interest. The question could say, calculate the amount in the account, or, calculate the final amount or the accumulated amount if simple interest is earned on 15,000 deposited. So we would lose marks. That's the wrong answer. If it said, I want the amount, then we've got to go, oh, okay, we started with $15,000 plus the interest. Okay, so the amount in the account, 15,956.25. So just got to be careful that you read the question carefully. So this one is this time not asking for interest, but asking for the total amount accumulated. So we invest 5,000 for 18 months, simple interest 9.5%. Again, where we could use a formula. Alternatively, let's find 1 year's worth of interest, 5,000 times 9.5%. That'll give me 1 year's worth of interest. Then multiply by 18 months, which is 1.5 years. So multiply it out and we'll get our answer 712, but that's not the answer we want. Oh, sorry, it says total interest accumulated. It didn't say the total amount in the account, so that's okay. We're still solving it okay. You just have to read the question carefully. Okay. The next part is, it says, what's the maturity value of the principal? So this time, okay, you started with 5,000, add your interest, 712, and you've got what's in the account. This loan company lending a customer $500 state it must be repaid at the end of the month and at 560 is going to be charged. So they're charging you $60 worth of interest for 1 month. What's the annual simple interest rate? What are they charging? Here, yeah, we could go looking for the right formula, but by the time you found the formula, you might as well just use this logic principle and solve it without a formula. So the deal is, hey, again, the key is always, I need to find 1 year's worth of interest. So I know what 1 month's worth of interest is, 500 minus the 560, $60 per month. What's 1 year's worth of interest? Multiply it by 12. So I've got $720 for the year, put it over the original amount that we borrowed, $500, and I've got 1.44 to convert that to a percentage. Times 100. So we've been charged 144%. We're being ripped off big time. Janelle wishes to have an amount of $4,000 on maturity in 5 years. Simple interest is 12%. How much money should she invest now in order to achieve her aim? this is the one time that a formula would be handy with simple interest. We can still write our own using common sense principles, but we do need to know a little bit of algebra to be able to do that. So here is us looking for the right equation, making sure we find the right equation and plugging the data in and getting the answer. But let's try and use logic to solve it. And what we're saying is, and I know I probably shouldn't use these terms. I'm using PV, which is really a compound interest term, I guess, but it's a value today, a present value. And I'm also using FV for the future value. They're using S for the future value and P for the original deposit, if you like, or the amount invested. And they're also using R for rate and T for time. I'm sticking with a compound interest, I for interest and N for, but I hope that doesn't confuse you. Technically, I'm probably doing the wrong thing, but stay with me for a minute anyway. So what we're saying is, look, whatever I invested today, the PV, I'm not sure what that is yet, plus whatever that earns, present value times the interest times the number of periods, has to equal the future value. So we're going to plug in what we do know to find what we don't. But before we do that, let's just expand the brackets. And when we do that, we're really saying, let's take present value out. And we're saying, really, present value times 1 equals the present value. 1 plus present value times 1 will equal the present value. So this formula here is saying exactly the same thing as the formula above. And what we're really saying is that if $1 earns this much interest and we invested $1, forget the present value for the moment, what would we have? We'd have the dollar that we started with plus whatever $1 has earned. So therefore, $200 will earn 200 lots of whatever $1 would have earned. $300 will earn 300 lots of whatever $1 would have earned. So that's the logic behind what's going on with this formula. $500 will equal 500 times whatever this $1 will have earned. So therefore, we've got it pretty much into that formula there that they're showing. We're saying, look, the present value has to equal the future value divided by 1 plus the interest times the 1 plus the interest, because 1 times I is I times N. That's essentially the same formula. So let's work it out. What's $1 going to earn? $1 plus the interest on that dollar. So is $1.60. So we're really saying that it's the future value, 4,000 divided by $1.60, which should be the answer, $2,500. Let's put it back in just to make sure it makes sense. $2,500 plus what's the interest that $2,500 earns should equal 4,000, and it does. How long will it take for an investment of $16,000? Now I'm just going to check that that this is working. Just got it running on another computer to make sure that what you're seeing is what I'm seeing. Yeah, how long will it take for an investment of $16,000 to earn that much interest if it attracts a simple interest rate of 3.25% per annum? Again, yeah, we could go looking for the right formula and solve it, or make T, time, the subject of the formula. That's one way of doing it. Alternatively, let's just use our logic again to say we're trying to find 1 year's worth of interest. Well, how can we do that? We know what the total interest is. That's not going to help. But we do know what the interest rate is, and we do know what the amount is. Because it's flat, it's never going to change. So $16,000 times 3.25%, that is going to give me 1 year's worth of interest. So now I know 1 year's worth of interest is 520. What's the total interest? How many years worth is in that 2860? 2860 divided by 520, 5.5 years is the answer. This time we've got a bank account. Interest is being paid on the, I think, being paid at 2.5% on the minimum monthly balance. We're going to calculate the interest due each month and the total interest for the year ended 30th of April 2016. The writer of the textbook is suggesting this time we should really do a table to work out what the minimum monthly balances are. So let's do that on the next slide. So let's start. He puts the money in on the 15th of October. I think you might disagree with me, but I think he's made a mistake here. He's saying, oh, well, the minimum balance in the account for the month of October, sorry, I do apologize, it's November. Obviously, the minimum balance for October is 0, but no, we're doing it for November. So fair enough, by the start of November, we've got $1,000 in. As long as we didn't touch it, which we did, we put some more money in. What a shame. Halfway through the month, we put $2,500 in, but it doesn't count. Only the $1,000 that we started November with counts. So we'll calculate 1 month's worth of interest, $1,000 on that minimum balance, times 0.025 for the year. So we've got to divide by 12 to get 1 month's worth of interest. 2.08 would be the interest for November. We've got to do the same for December. Go looking for, whoops, unfortunately, he took out $800. So even though he started the month of December with $3,500 in, he's taken out $800. So he's going to only earn interest on the minimum balance, $2,700, and work out what the interest is on that using the same principle there. We keep going for January. He puts a bit more money in. Unfortunately, it doesn't count. So for the month of January, he's only going to earn interest on the minimum monthly balance of $2,700. What he started January with. Have a look for February. It looks like he didn't touch it at all. So $3,450 should be good for February. So what happens with March? He puts $400 in, which is lovely, but he started the month with $3,450 in, so that really doesn't count. And then he took $1,400 out. So essentially, his minimum monthly balance for what's the smallest balance? Oh, so sorry, he put another $1,400 in. Too bad, doesn't count. It really is what did he start the month with? And the answer is I think the answer should be, yeah, because he took $400 out, $3,050. Okay, so that hopefully you've got the principle there. We just keep following that. Watch the dates. Be careful. You can easily trip yourself up. So I've got to keep looking for the smallest amount. There's this short-term rule of thumb formula, if you like. It's not exact. We're about to prove that it's not exact, actually. But what it attempts to do is convert a flat rate of interest to what the effective rate of interest is. The fact that you pay this higher rate of interest, even though you might have paid back the loan, you're still paying this high flat rate of interest. So the effective rate of interest is equal to 2 times the number of repayments times whatever the flat rate of interest is over the number of repayments plus 1. So a customer takes out a $15,000 personal loan from a finance company, repaid monthly over 5 years. The flat rate of interest is 9.5%. We're going to work out what the total simple interest is on the loan and what is the equivalent effective rate of interest. So pretty straightforward to work out total interest. 15,000 times 0.095 will give me 1 year's worth of interest times 5 years. Just make sure, yes, so total interest payable is 7,125. Let's plug in just straight into this formula to work out what the effective rate of interest is. So it's always 2 times how many repayments? Well, because they're monthly repayments and it's 5 years, 5 12s is 60, times the flat rate of interest. Again, we're going to key it in as a decimal, 0.095, and divide by the number of repayments plus 1, 61. And we get an answer of 18.69. It's that's our estimate of what the real rate of interest. But let's have a look at this in Excel and prove it and find out how close this formula is to getting that answer right. So here's that same question. So the first thing to do is just work out what the monthly repayments might be. So we worked out what the simple interest is. I might make this a little bit bigger for you. We worked out what the simple interest is, and then we're going to pay back the loan. So the total amount that we need to repay is that, and then we're just going to divide by 60 to work out our monthly repayments. So here we are. If we scroll down to the actual, spreadsheet, 60 payments, 60 lines down, paying it off. Let's work out how this works. We started with 15,000 and just using the flat rate of interest, give me whatever that balance is of 15,000. Always that $N, $5 is always finding the 15,000. Multiplied by 0.095 divided by 12, 1 month's worth of interest keyed in there, never changes. Even though we start repaying the balance, we're still paying it as if we owed $15,000. And there's our repayment of $368. So opening balance, add interest, subtract repayment, gives us our closing balance. So there's that formula. Once we've written that formula, we can pretty much drag, just make sure, no, sorry, it's the second line of the formula, because then we're going to say, let the opening balance equal the closing balance. And once we've dragged that formula down and that formula down, by clicking on there and grabbing the little fat white cross becomes a thin black one, drag it down. Once you've done that, pretty much it repeats. So you can highlight the cells and go all the way down. And that will write, we've only had to write 2 lines of formulas, and that will go all the way down once we drag it down to the final balance. So we know we're right because everything's paid off perfectly at the end of 60 months. Well, let's try and work out what the effective rate of interest based on that formula that we calculated a moment ago was suggesting it was 18.69. So let's use that instead of 9.5%. But we're going to use it on a reducing balance this time, not on the flat 15,000, and see if they work out, see if it gets you back to 0. So bring in the opening balance, interest being charged. Now this time it's relative. We're not putting $signs on it. We're making it relative to the opening balance. So whatever, as the opening balance drops, so will the interest start to drop. But we are charging it at a higher rate. Whatever's here in cell 013, we've put $signs on it, so it always finds whatever's in here, 18.69. Then it divides by 12 to find 1 month's worth of interest. We're going to run with this flat repayment of $368.75 that we calculated for simple interest. The assumption is that if we get it right, we should have repaid the loan perfectly. Same formula here. Let the closing balance equal opening balance, add interest, minus repayment. Then let the opening balance for month 2 equal the closing balance at the end of month 1. So let this cell here, we just go equal that cell there, enter. Do the same sort of thing. We'll write our formula, let this equal, click on it, click on that cell, put the $signs in, and then divide by 12, hit the enter key, and you've written your formulas for your second line. Drag it all the way down. Let's see what happens. Fingers crossed. Using 18.69, whoops, it didn't quite make it. So 18.69 still left some money in the account. So we're hitting it too hard. We're charging too much interest. It's not exactly 18.629. So what we could do, we could use this handy little Excel feature called Goal Seek. And the way it works is it just is like a trial and error approach. It keeps calculating and calculating it hundreds and hundreds of times until it finds a solution. So the way to make Goal Seek work is all of these formulas you've got to go to where you want the final answer to be, which is down here. We want Goal Seek to work so that this figure here will equal 0. We don't want it to equal 1746. So then to pull up Goal Seek, we click on the Data tab, and goal seek's over in the what if analysis. Click on the drop down what if, and we say goal seek. And it says, what would you like this cell here to equal? And we'll say 0. And it says, well, by changing what? It allows you to hold everything constant except one thing. And the one thing we do want to change, the one thing we want to find the answer on, is the interest rate. We press OK. Bam. Did you see it looping? It's going through, trying to find a loop. And it finds, yeah, look, the real answer is 16.49. And when we start using 16.49, we go down the bottom. Of course, it's perfectly paid off. So that estimate of the effective rate of interest is really only an estimate, but it's pretty close. We know it's definitely not 9.5%. So we're a little bit out, but it gives us a bit of a hint, a bit of an idea as to what the real rate might be. And the advantage of Excel is it really is very, very helpful. We'll use Excel quite a bit in our studies to solve a whole lot of practical problems. So there it is. We've explained that. And here we are doing the inverse, if you like. It's saying, look, these guys have an effective rate of 11.5. Could you calculate the effective rate, calculate the equivalent rate of interest? The equivalent flat rate. So it's just rearranging that previous formula to say the flat rate of interest must be basically by rearranging that formula you saw 2 slides ago. Rearranging that, making R the flat rate of the formula, and rearrange it, and you get, we won't do it yet, but you could, if you want to practice your algebra, have a practice at rearranging it, and you'll get this formula here. And then we just plug the data in. The period, number of periods, 240 plus 1. Why is it 240? Because it's 20 years and they're monthly. So 20 times 12, 240. So 240 plus 1 times the flat rate of interest, the effective rate of interest, 0.115, divided by 2 times the number of periods. And we get a flat rate of interest. We are expecting an answer to be lower, it's almost half. 0.057745, 0.774 is pretty close to the equivalent flat rate of interest. All right, well, look, I'm going to stop this recording now, and you might want to take a break, and then we'll come back and do compound interest. Hoping I'm doing the right thing here. This is, yeah, fantastic.